Next up, we have someone who almost needs no introduction at this point, Byron, who is one of the co-creators and current maintainers of GraphQL, the spec, and the reference implementation. Previously at Facebook, he's worked on Immutable JS and React, amongst other cool, snazzy things. So welcome, Lee.
Thank you. Yeah. How many people here have not heard of GraphQL subscriptions before? Cool. This is good, because I'm going to go deep, so I'm not going to give like a high-level overview. Let me make sure that this is not mirrored. You would think that they'd figure this stuff out. Every time you plug in a projector, you got to redo all the stuff. Come on, Apple.
Windows figured it out.
Don't tempt me. All right. Hello, everybody. My name is Lee. I'm going to talk about GraphQL subscriptions today. Specifically, how do they work? Do they work at all? Let's find out. I have a handful of slides that show code, but in my opinion, the code itself is not actually that novel or interesting, and that's a good thing. And what's actually really interesting here are the core concepts and the abstractions that are involved and how we can combine those things together to create super flexible architectures. Another way to kind of like phrase this presentation is that we used to have this interview question at Facebook. We don't ask it anymore, so I think it's pretty safe for me to divulge what it is now. Where you would say, you're sitting at your computer and you type in facebook.com and you hit enter, tell me what happens. And like a bad answer is facebook.com loads, and a good answer is, well, first an electrical signal goes from your key to the keyboard bus. Wait, how much time do I have? That's a good answer. So that's kind of what I want to do here is like start at a super high level and then start to like unpack the abstraction. And at the end of this, what I want to get to is kind of some like real world takeaways that you can have on how to actually build one of these things and scale it. And that's pretty far away from where we'll start. So let's see how far we can get. Let's start with the most abstract possible definition of these things, the spec. So this is actually really exciting because this landed in the spec like a week ago. There's still some details to work out, so this is not a released draft of the GraphQL spec yet, but here we have it. So if the operation is a subscription, then the result is an event stream called the response stream, where each event in the event stream is the result of executing the operation for each new event on the underlying source stream. That makes sense. Here's the key phrase, event stream. This is super clutch. This is the whole deal. This is everything about what makes GraphQL subscriptions. So let's start there. Event streams. So event streams are a conceptual model, an abstraction. There's lots of different ways to implement these things. That's part of why we talk about them in the spec in terms of a conceptual model, is we want people to be able to implement them in lots of different ways. We don't want to like enforce that you use like RxJS or something like that. So let's first look at this as a conceptual model, then we'll show a little bit of code. So an event stream is a stream of things that happen over time. Hopefully obvious from the name of this thing. So you get these things that come in like this. And we got a couple things here. Oh yeah, and then at some point it can close. So we have some concepts. This thing is an event stream. This is a piece of data, an event that happened on that event stream. And at some point, most event streams complete, which is basically their way of saying no more events will happen on this stream. Some other stuff can happen. So you could be happily getting some data, and then all of a sudden you get an error. And errors are always followed by a completion. And so it's important that we can represent both a piece of data flowing through the system and an error flowing through the system, because we might want to handle those two cases differently. One other case that we want to make sure we cover in this abstraction is the idea of a consumer, right? So event stream has these things that happen, but if nobody's listening, then kind of what's the point? So we have this consumer. So as these events are coming in, they're getting consumed by the consumer. And at any point, not only could this event stream close and tell the consumer, hey, I don't have any more events for you, but also the consumer could send a cancellation, which basically says, even if you had more things to send me, I don't care, please send me a completion. So that's the last major thing that can happen with event streams. So event streams are pretty cool. You can do a lot of interesting things with them. One super important concept to make sure we get up front is an event stream mapper, and we actually use this in the definition of GraphQL subscriptions. So an event stream mapper is cool because what it does is it takes in an event stream and it returns a new event stream, and then as events come in, they can kind of get reshaped and come out the other side in the other event stream in a different form. So a mapper is kind of like a function. It's somewhere in the monoid family. I don't understand that stuff, but I'm pretty sure that's half true. Right. If you get an error, those things just pass through. Those don't get mapped. So that's almost always true. And then completion events also go all the way through. So when the event stream that you're mapping over closes, you also close your mapped event stream. So that's an event stream mapper. So these are the two kind of building blocks that we'll use to define how this stuff works. So let's take a break and look at some code. This will be actually the only code in the whole presentation. Is event streams, if you've kind of been around the block, you probably read some code where you're like, I know what event streams are. I know I've written some node streams. Very cool. Node streams are an implementation of this exact idea. So you can create a stream, and then you can say, hey, when I get data, I want to do something. And if there's an error, then I want to do this other thing. And then once this thing ends, then I want to do that thing. And we also have this concept of cancellation that's also there. And I don't have a line of code up here, but there's this concept of through streams, which is basically the idea of a event stream mapper. So we have everything we need with node streams. So that's one way that you can implement this idea. Another one is Rx Observable. So if anybody who's messed around with RxJS or RxJava or RxSwift, observables are another implementation of this exact same abstraction. So you can create an observable, and then what you do is you subscribe to that observable, and you can pass some callbacks. So you can say, here's the callback to call when you get some data, here's the callback to call when you get an error, and here's the callback to call when there's nothing left on a completion. And then there's also an API for cancellation. So again, we have all the pieces that we need. And if you look at RxJS or any of the other Rx libraries, they come with not only map, but like a plethora of other tools that you can use to operate on these things. Another one that should be familiar to JavaScript developers, I hope, because it was part of the ES6 spec that launched 2 years ago now, is iterators. So iterators are cool because they're almost this concept, but not quite. And I'll show you why. So iterators, you can create them, and then what you do is you say, well, I want the next piece of information, and then you get back this kind of tuple. You can ask, is it done or not? And then you can kind of decide what you want to do there. And then if it's not done, then you usually have a value, and you can do something with that value. Otherwise, it throws an error when you call next, and you can do whatever you wanted to do with errors. And then we also have this idea of cancellation. So this is not specific to all iterators, but any iterators that are generators. So subclass of iterators, you can call this return function, which will cancel it. So this is cool, but everything we talked about so far is this idea that events will kind of be pushed to us. And here we have to call next, which means we're trying to pull events out and get them immediately, which can't always work. Sometimes our buffer might be empty, or we might just be waiting. And we can't block in JavaScript. And actually, we can't block in a lot of different programming languages. So this doesn't work. But good news is that there's a new proposal to JavaScript that's super exciting called Async Iterator that kind of gets around this problem. So we have all the pieces that we need now. We can create one of these things. It kind of works like an iterator. We call next, but when we call next, we get back a promise. And when that promise resolves, then it resolves to the same tuple where we have done. We can see if it's the completion. And if it's not done, then we have a value that we can use. And then since it's a promise, we can also capture errors and have a callback there. And then we have the same exact API for cancellation. So this is cool because it's the exact same API that we wanted, that we got with node streams, that we got with observables. So why would you use async iterators instead of observables? Observables are cool. This got specified, but who cares? The answer is because it's becoming part of the JavaScript ecosystem at a core level. That means we'll have new syntax for working with these, so they'll feel very, very familiar to the actual programming language of JavaScript, which is super cool. So we can replace that code with some new code that does exactly the same thing. This time we can write a special kind of for loop called a for await loop. And what this will do is it will do that like .next, .then kind of handling for you in the background. And every time a new message is pulled and resolved, then your loop iterator will call, and you can do something with that. Otherwise, this thing will throw. You can catch that error. And then you can use the really nice try catch finally loop to handle your completion. So this is pretty cool because this reads like standard synchronous code execution, but this is actually syntax sugar for the exact same slide that I showed you before. Another cool thing is not only is it syntactically baked in to be able to operate on these things, but there's also syntax for making them. So if I wanted to make this create async iterator function that I just used, it might look something like this. Now there's some like weird decorators happening on this function. This is definitely not a normal function. It's an async function, which you might have heard a little bit about if you've messed around with async await, which usually return promises. But it's also a function star, which is a generator function, which has actually been around in JavaScript for like almost 10 years. Like Firefox has had this thing forever and ever and ever. So there's been an open question for years in the JavaScript committee of what happens when you use both of these two things at the same time. And for a long time, the answer was, oh, it's easy. It's a syntax error. Don't do that. But we think this is the answer. So this is stage 3 in the JavaScript process, which basically means one step away from being totally baked into the spec. So if you use both async and star, you get an async iterator. And that's cool because you can both use await, like you could use in an async function, and you can use yield, like you would use in a function star generator function. So yield is cool because every time you yield, it pushes out another one of these events. And you could do that as many times as you want. You could do this in a loop. You could connect this to some other random service and have that do these things. You could operate on them. This is super cool. So you can kind of mix and match the worlds of promises, generators, and async iterators all together in syntax. So this is awesome. I'll get back to why this is exciting kind of at the end of the presentation. All right, GraphQL subscriptions. We've got our abstraction down. We have everything we need to understand GraphQL subscriptions, right? Almost. First, we should have a super quick refresher on how GraphQL queries work. So with GraphQL queries, there's 3 important steps. We've got parse, validate, execute. And what happens is when we get one of these requests in, parse will turn it into a syntax tree. Syntax tree will be validated, usually against your schema. Make sure that you're not asking for something that doesn't exist. You haven't done something totally squirrely. That goes to the executor. Executor will turn that into your payload, send the payload back to your... does that. It's got to take a little bit of time, and then off it goes. So with subscriptions, this should be pretty easy, right? Like we're just going to take this execute box and swap it out with subscribe box. Done. Except that before we were just kind of returning this response, and now we're not doing that anymore. So what's going to happen here is instead of returning a response, we're going to return one of these event streams. So we're going to do the same few steps, but now once it gets to subscribe, we're going to immediately turn one of these event streams. And now we can start issuing these yielded payloads, or event data along this event stream and send all of those to the client. And then, of course, the client can cancel us. We can close their event stream. So this is kind of it. This is how GraphQL subscriptions works. But of course, I promised you that we would slowly start to unpack the envelope and see how far down the rabbit hole we can go. So what's actually happening here in subscribe? How did we go from having a valid query to having an event stream? How did that work? Well, let's take this box apart. So subscribe itself is actually defined in terms of 2 operations. It's create source, and then it's one of these mappers. So create source is this thing that takes in this validated query and returns an event stream. And then our mapper is going to map that to a new event stream. That way, we can send in one of these events, and I can't see my screen. And then the thing came out. So how's that work? Well, the mapper is actually going to map these event streams by using the existing GraphQL execution function. So we're going to recycle that from before. And now here's what's actually going on, is that event goes down into the executor. That's going to do whatever it's got to do, send the response back up, and back off to the client. All right, now we have to add our consumer. The consumer is the client. And let's not forget that these steps still exist. So now we actually have a pretty good picture of all of GraphQL subscriptions with this box unpacked. So let's kind of see this all in action. So we've sent a request, parsed it, validated it, put it into create source. Now, create source has an important job to do, which is having received that request, it actually needs to do some work to figure out, well, what is this source event stream that needs to be returned? So it's going to do some work, then return that event stream. The mapper is going to return its own event stream back through to the client. And now that it's done that, we can start to send all these events through, which are going to the execution function, which is going to work on these things, send them back to the mapper. The mapper is going to send them on to the client. So this is kind of a complete picture of what's happening when we use GraphQL subscriptions. But maybe there's more. All right, let's see what's happening. Ah, yes, of course. If we cancel, the cancel goes through the mapper. We already saw that from our abstraction before. Create source closes. And this is actually a great opportunity for whatever the original source was that was created by create source to do any kind of cleanup. So say you had opened a connection to a pub sub service. Getting that cancellation might be a good opportunity to close your connection to the pub sub service, something like that. So that's it. That's basically, as far as we've gotten so far, is what is written down in the GraphQL specification. The clauses and all the defined algorithms, I basically have already covered just using kind of colorful boxes and arrows. But what this leaves us with is sort of some unresolved implementation details that we're responsible for filling in. And that's very much on purpose. What the spec wants to do is only paint the abstraction for how this works. That way we can fill in the blanks however we need to build kind of a myriad of different kinds of services. So first, let's look at this create source box. What are some of the things that we might do to implement that? Well, a really obvious one, and one we talk about all the time, is we'd want to subscribe to a pub sub topic. And this was the original motivating force for building GraphQL subscriptions at Facebook a couple of years ago. When we talk about it publicly, we talk about GraphQL subscriptions as a way to put GraphQL on top of your pub sub system. So obviously, this is a great place to start. But we could do other things. Another thing we might want to do is maybe watch for database writes onto a database that will give us a live stream of writes that arrive. That way, we could trigger queries that say, hey, somebody just edited this thing that you're subscribed to, so I want to tell you about that. We could process a Kafka stream. Kafka is a super cool library and framework that if you haven't checked that out, you probably should. It's a pretty awesome way to build a microservices architecture and then have this sort of real-time system working within it. You could do something totally different from that, right? You could just tail a file. That's fine. Or you could listen for incoming HTTP calls. I don't know. We got an endless set of things we could do here. We could listen to incoming stock prices from a stock ticker, whatever. Anything that's going to tick data at us at a reasonable rate of time is a totally reasonable implementation for this function for creating a source. So if you put this stuff back, there's kind of another problem here that I glossed over so far, and that's the internet probably needs to go somewhere, right? We've got this GraphQL thing. We said there's a client. How does this work across the internet? The GraphQL spec leaves this up to you, but there's some nice ways to think about this. So the way that we think about this is that between GraphQL and the client, there is this thing called a transport. And in typical GraphQL, this is usually just HTTP, and this transport's pretty simple, right? A request comes in, it might be a GET request or a POST request. You forward that on to GraphQL. GraphQL's here's some JSON to give you back, and you're like, cool, this will be the body of my HTTP response. So that's a pretty easy transport, but when we get to subscriptions, transports can get a little bit more complicated. So transport's really two halves. There's the server's half of the transport, and then there's the client's half of the transport, and then there's some protocol messages that are going to happen back and forth. So for HTTP, this might be TCP packets flying back and forth. But for subscriptions, this might be something else. So now where we are is this client's going to send us a request. Once we've gotten that request, then the client side of this transport is going to all right, I need to talk to my GraphQL server, so let's open a connection. Once that connection is open, then we can send a packet that represents what we want to do to GraphQL. And then on the other side of this transport, it's going to turn into something GraphQL understands. GraphQL is going to say, cool, here's this event stream that I want to give you. Our thing's going to then wrap that up, send these packets across. And now every time we send one of these events, our transport has to come up with some way to serialize that, send it in packets across the internet, put those packets back together, and then hand those back to the client. So there's a lot of really pretty complicated work that needs to go on in order to make this actually possible. So let's take a quick look at this thing. Maybe what are some ways that we could implement that? Well, one that we talk about a lot is WebSockets. WebSockets is pretty cool because it's kind of built into almost every major browser at this point. So that's a really good one. Some other ones are other like messaging protocols. So this might be MQTT or 0MQ or RabbitMQ or something like that. We actually make large use of MQTT at Facebook. It's a pretty major client-side transport for us. Maybe we want to post to a webhook callback. This is one that I think gets undersold in the conversation of subscriptions. I think GraphQL subscriptions and API webhooks are like a match made in heaven. That when you sort of subscribe to a webhook, you might send a GraphQL subscription request along with that, and then also provide the HTTP callback URL that you'd want to be hit, and then we can kind of post messages to you as they come in. So that might be a way to do this as well. Or I don't know, send an email, or like literally any way that you could kind of transmit messages, multiple messages over time. It's all up to you. So, don't let only the handful of things that are already stuck in the world of asynchronous message sending be the end of your investigations. So now that we've seen kind of the pieces, both at the abstraction layer and the pieces that we need to implement for ourselves, let's talk about some of the problems that we're going to find when we actually want to productionalize one of these systems. So probably the first problem you're going to run into is your client's going to want to send more than one subscription. So a really clear example for us at Facebook is listening to the number of likes on a story in your newsfeed. So as you're scrolling through newsfeed stories, we're actually creating and unsubscribing from subscriptions as you scroll. That way, whatever's in the viewport, we're keeping those, we call them our feedback interfaces. We're keeping the feedback interface as up to date as possible. The thing is, as you're scrolling and another story comes in and you're creating one of those, well, you've already got this whole end-to-end thing hooked up. So what do, right? Like, do you make another one? Do you open a new WebSocket and like call through to GraphQL? I guess you could do that, but I think it's pretty obvious why this might be not the right answer. Eventually, your client's going to run out of sockets. That's going to suck. Your server's going to have huge incoming load. You're going to have one user tied to multiple servers if you've scaled the number of machines you have. This is probably not the right answer. So what is the right answer? So I think multiplexing is a really cool tool that you can use to do this. So the way that works is that your transport needs to understand that there might be multiple things happening on that transport at the same time. So usually your browser is actually doing this for you. So a browser will multiplex requests using the URL. So if I say, I want to load these 10 images, and then the server starts sending me back responses, and it's like, by the way, this is a response for this URL, and that's the response for that URL, that's multiplexing. I know as each of these packets are coming back, which resource they belong to. So I need a similar solution here as I want to say, hey, I need a new connection to my transport. The transport says, cool, I already have one of those open, so I'm going to go ahead and send to my existing transport a request for a new subscription. That's going to send to GraphQL. Now, GraphQL can have two open event streams pointed at the same transport. And now, as we send these things back, we can kind of wrap them up in with a little bit of metadata about what stream they came from. That way, on the other side, we can deconstruct those back into the appropriate streams. So this is an important thing to get right. It's one of the first things you'll probably bump into. All right. Oh yeah, I talked about multiplexing. So scaling. So far, everything we've talked about, all of our boxes, kind of assume that everything's happening on one machine. Now, that might be okay if you're at a hackathon, you're making something really quick. But if you're lucky enough to have thousands of users even, tens of thousands of users definitely, one box is not going to cut it. You're going to need to scale. And this makes things a little bit tricky, because before, if we're only handling queries and mutations, those are stateless. So the request comes in, you resolve it as quickly as possible, you send the response back, you close the connection, you get out of there. You can handle lots of incoming requests. And today's modern boxes with good software can handle tens of thousands of requests pretty easily. But subscriptions are long-lived, so each active subscription is going to count against the number of sockets that you have open, or the number of work that's happening on that machine, or amount of state and memory that's holding on to. So you're definitely not going to do tens of thousands of requests a second on a machine that's responsible for scaling. So one of the first things that you might want to do is chop up this server-side diagram into two pieces. So you're going to say, I'm going to take the execution engine, put it in its own service, and then I'm going to take everything that's stateful and keep it in a stateful service. So now you have these two pieces. That way, if you want to scale these things up, you could actually have many execution services. And as you're getting these packets from your source and you want to run them, you could just send them to whatever execution service happens to be available to do some work. And then if you need to scale up the number of subscription servers that you have, you can kind of do that independently. So if you realize, oh man, I get tons of incoming queries and mutations, plus this incoming subscription load, I need 100 nodes to handle that. But subscriptions is comparatively lighter, but each box only handles so many consecutive connections, so maybe I need like 10 of those. So you can scale these independently of one another. That's going to be really important. The next thing is, this create source, it's going to talk to something, right? Like, we're going to talk to some database or pub subsystem or stream publisher or something like that. And as we scale the number of boxes that we have, if we're hammering one of these things, eventually that thing's also going to run into scaling problems, right? And again, this is maybe not that hard to scale if you're only doing queries and mutations. I think it's pretty easy at this point to understand how like read slaves from MySQL work, or actually a lot of cloud services just have kind of like, you don't even think about it, they just scale your read-only database reads for you. But with subscriptions, this gets a little bit trickier. So as you start to scale up the number of machines that you have for storing information, you're not just storing information, you're also pushing all these events around. So now that you have all these things happening with events, maybe the source of the event happened on this box over here that you're not paying attention to. And so you need to make sure that all of these boxes are talking to each other so that that box can say, okay, something's happening, and then push things back up. So making sure that you're thinking about scaling all of these three pieces independently is also tricky. So another thing that you might bump into is throttling. So throttling is important when you're not sure what the rate of these errors is going to be. So this got really important for us at Facebook. Let's go back to our diagram here. Going back to my example from before, listening to the likes and the feedback on a story. So if you're scrolling through your newsfeed on Facebook and you see some posts from your friends, well, if somebody likes your friend's post or writes a comment on it, you probably want to get that information in a timely manner. And you really don't want to lose out on that. If stuff's happening, you want to see it because you're looking at it in your newsfeed. But if in the process of doing that, you scroll by a post by like Lady Gaga or Barack Obama or even Mark Zuckerberg, then those posts get like hundreds of likes a second. Like, it's crazy. You do not want hundreds of like events getting pushed to your device. Like, it'll warm up. Your battery, you'll watch it like 60%, 59%, 58%, 57%. Like, oh no, what's happening? I hate Facebook, and you'll close the app, right? So that's bad. What we want to do is throttle these together, so if the rate exceeds some limit, that we start batching them together in a way that is still compatible with our GraphQL definition. So at Facebook, what this looks like for us is that we're just getting lots of these events pushed through, but then our source has a throttling service that makes sure that if these are coming through at a fast rate, that we're making sure that we're only then pushing them back through the GraphQL service at a reasonable rate that it can handle, so that it actually is pushing to the client in a way that won't melt the client. One last topic I want to cover is quality of service. So with quality of service, have you guys heard this term before? It basically means if I push you a packet, what do I want the guarantee to be? I could say, I'm going to push that packet to you once, and if you missed it, tough luck. Or it could mean, I'm going to try as hard as I can. If I haven't heard from you in a while, I'm going to call you again. It's like an overbearing mom. Like, that's quality of service too. Dad who doesn't care, quality of service 0. That's like the gamut right there. Let's go back to our diagram. OK, so here's the problem. Everything's been working well so far until our client just walked into a subway or drove through a tunnel, or like something happened and we lost them. This happens all the time. But even worse is we just got this event. It went through the whole system. We did all this work, and no one's there to listen. So now what? Well, I don't know. Like, this is for us to decide. Maybe it depends on the particular subscription. Like, for like counts updating, maybe it's OK for those to be dropped. But for a new message coming onto a message thread, probably important to hold on to that. So if our client comes back and they reconnect, maybe within a reasonable amount of time or whatever, then we can send that message back on. That's something? Cool. So that's kind of it. That's GraphQL Subscription in a nutshell, plus a handful of these things that you might encounter when trying to actually build one of these things in a productionalized manner. So I want to talk a little bit about where you can find these pieces if you want to start playing with this stuff and building it now, since a lot of it is pretty new. first I'll draw this box here. So we usually talk about creating a source and how that source maps to your executor as kind of one box. That's what we talk about as GraphQL subscriptions. So this piece here is part of GraphQL.js. So we actually released a, I would say like a technical preview of this. There's still some last minute details that we're kind of hammering out. So expect the API might change between now and the next version of that. But you can start playing with the early version of this. Of course, GraphQL.js already has parse, validate, and execute as part of it. So this subscribe piece with these two utilities is new. That's there. For the client, there's of course Relay and Apollo are both clients that understand subscriptions. And I should also say that you don't really need to use either of those if you're building something that doesn't need the complexity that either of these two clients bring you. They bring lots of features, but if you don't need that, something simpler is great. Again, reiterating, WebSockets is basically available to you on every major browser. So if all you want to do is say, hey, I'm going to consume WebSockets and then do stuff, that's great. Just go nuts with that. Then I didn't mention, but in GraphQL.js, the way that we've implemented these subscribe boxes is with async iterable. So when I talked before about how async iterable is becoming part of the JavaScript ecosystem, that's important to us because we want to be building a reference implementation that is going to grow well with the rest of the JavaScript ecosystem. So we've kind of gotten on the bandwagon early with Async Iterator. And that means as you're implementing these pieces, rather than doing something that's GraphQL specific or a certain library specific, you can just write something that is designed to work with any kind of JavaScript library. So if you're building one of these transports, this is one you can use today. It's called Subscriptions Transport WS, which stands for WebSockets. That's written by some of the engineers at Apollo. That will take in an async iterator and return you WebSockets. And it's got some additional logic that will make sure the right steps happen with respect to parsing and validating your GraphQL queries. And then, of course, there's the sources for these things. So there's a bunch of community-contributed implementations of these that will give you an async iterable for calling them, which is super cool. It means that not only can you use these with GraphQL subscriptions, but it's actually a really nice API on top of any of these kind of eventing systems. This one is really great if you're using Redis as your kind of pub subsystem. GraphQL Redis subscriptions will do this for you. And as I kind of mentioned, all of these things ideally will start to evolve with the JavaScript ecosystem and implement async iterators. So we should not have to wait for people to specifically build these for the GraphQL system. We should just hope that people will build these for async iterators in general, and they'll just happily work with GraphQL with hopefully very little additional work from us. So that's it for me. Any questions on this stuff? Yes. Oh, thank you. Yeah, I pride myself on my animations.
So one of the cases that I struggled with when I thought about these subscriptions is duplicate data. So if I make a traditional GraphQL query and I say subscribe to if I query for a user myself and then I query for a game which has users in it, and I'm in there as well, I get all that data back. Both of those instances of the user myself are the exact same. But then if I have two different subscriptions that contain myself as the user in both of these locations, and I get data back from this kind of asynchronous transport or whatever, my application can get into a state where it has myself as a user in two different states. So is there any effort into like deduplication of data, or would you just design the application differently? Or?
So let me try to rephrase your question as briefly as I can. As you're getting data from lots of different sources, how do you dedupe that in a way so that you're not getting inconsistencies? I highly recommend checking out Relay Modern or the Apollo client, which that's basically their #1 job, is the deduplication of data and making sure that whatever the most recent data that is seen is the data that is displayed everywhere, no matter where you got it. So both Apollo Client and Relay Modern both implement this idea. So this is super cool when used in context with subscriptions, because what you can do is say you're Facebook and you're building newsfeed and you're scrolling through these stories and you're subscribing to comments. And one of the things that you want to be aware of is if somebody changes their profile picture. Actually happens all the time. People will be in the middle of a thread and they'll change their profile picture and they'll hop back and they'll continue to chat. It's super cool when you're doing that. Someone changes their profile picture and all of a sudden it shows up in the UI everywhere. That's because one message got pushed, We include that because it's relatively cheap to include in that response. We can look at that, we can compare it to the one we had before, notice that it changed, and then refresh any part of the UI that might have that person's profile picture in it. So that's one way to do it. Another way is trying to handle that at the transport layer. So one of the presentations at GraphQL Europe talked about using GraphQL subscriptions alongside a GraphQL query to say, maybe I want to fetch all of something that exists at the time, and then I want to open a subscription for new ones that come in. So say I'm building a game, and I want to know all the players in a game. So when I show up, I want to know who's here now, and so there's 10 players, and now I want to open a subscription, so any players that show up after I did, I get notified that they joined. So there's this sort of temporal gap between running the query and having the subscription set up where you can kind of lose on either side, right? Like you either have this temporal gap where you're not listening and someone might join the game before the subscription set up, and then now you have this person in the game that you didn't even know was there and you've lost some information. Or you set it up where you send the subscription up first and then you send the query, and now you might get duplicated data, right? You might get a subscription payload that says somebody's joined the game right as your GraphQL query is coming back that says, hey, this person's in the game. You're like, I know, I just got a subscription about it. So at worst, in the case where you have the gap, you have missing information, sort of mediocrely at best, you have the case where you're getting multiple payloads for the same information that you're getting multiple times, which is not as efficient as is optimal. And doing it at the transport layer might be a way to solve that. So one of the tools that we've built at GraphQL, or at Facebook, is called GraphQL Batch. It lets us send multiple queries, and we do not have this feature yet, although I imagine at some point, if we run into this exact scenario, it might force us to try to build it, is sending both a query and a subscription at the same time, and then make sure that those can execute in sort of an atomic manner on the server where we can control for the temporal divide. But honestly, we haven't actually run into that case, and it's more important to us to not miss data than it is to get slightly duplicated data. And so if we're getting one push notification more than we need, that's usually okay for us.
So, little caveat. What I was thinking is that if you have these two subscriptions, you might get an update for the user, and then your user will be in two different states. But I think your question earlier, or your response earlier,
Yeah, avoiding the two different states, you want to use something that will normalize your data, which is Relay or Apollo client. Yeah. Other question? Yeah.
So if you have one definition with two subscription operations in it, like for instance, listening for likes and then listening for profile picture, you set up your event source that you're listening to two different streams. One of the events comes in, you re-execute it. What are you doing with right, that event only applies to one of the operations?
Yeah. Great question. So to repeat, what happens if you have a subscription that has more than one subscription operations in it? And the answer is it invalidates. We don't run it at all. And this is actually, it's a great question because it was one that was sort of one of the core questions that we were trying to answer as we were going through the spec process. And it turns out to be a can of worms. There's all kinds of super weird, you're scratching at the right first piece of that can of worms of whoa, what do you do with this other thing that's sitting over here that you might have an event for? What happens if you get two events simultaneously? Do you merge them? Oh, I don't know. This is hairy. And so the answer was, let's punt. And so to punt on that, we couldn't leave it undefined because that would mean that every server would kind of come up with their own definition for what that meant and handle the edge cases in their own way, which would mean skew between all the different servers, which is something that we'd like to avoid. So instead, we decided that should be invalid. So if you have more than one operation in a single subscription request, we just say you can't do that. And then if you want to have multiple ones, the answer is use multiplexing on your transport, open up multiple subscriptions. It's not going to be additional resources on your server because you're still going to share that one connection. You're still going to create two source event streams. It's going to set up the same amount of resources, but there's going to be much better definition about what can happen and when and why. Other questions? Happy to answer non-subscription related questions as well if people have those too, but any others? None? No questions? You guys are easy. You're just waiting to drink more beer.
I think that is approaching the end of our meetup. But thanks so much, Lee, for coming. That was awesome.